Hello, students. We are into 12-2. This is Math Connections number 16. A student says she knows a parallelogram has two heights. That's the distance between the parallel sides. But when it's long and narrow, she does not know how to construct the altitude to the shorter sides. How do you respond? All right, well, let's talk. We're talking about a distance. Distance has to be measured by the shortest path. Okay, so let's just briefly talk about what that would look like as an example. If I was to say, what is the distance from point B to the line AD, the distance would not be right here, right? This is not the distance. The reason it's not the distance is it's not the shortest path. When you think about a shortest path, if you wanted to, you could use your compass to create this, but the idea is I want the shortest path, and that shortest path has to be perpendicular. This is very similar. I want you to picture, what if the shape was this instead of the parallelogram? If it was just a triangle, that triangle would have what is called an altitude. The altitude of a triangle goes from a point perpendicular to the side opposite. Okay, has to be perpendicular. That's the altitude. And that altitude is the height of the triangle. And I think that also makes sense. If you were climbing a mountain, the height would be like the elevation, if you will. Right? So elevation, there's my height. And now what are we looking at? It's like if you were hiking the mountain, you'd have to walk up the side. Walked 3 miles. It doesn't mean you went 3 miles straight up. Right? So straight up and down is the height, or the altitude is the name of the segment that we draw. So it's very similar over here. So what I would do is I just picture triangles if you're having trouble trying to figure out how would you construct the altitude to the shorter sides. Okay. And remember, if you had a triangle and the triangle was obtuse like this, then where is the altitude to this point? So just remember what I've said, the definition of an altitude. It's from a point to the side opposite. The side opposite is over here. Now, if you want to draw it this direction, that's great, but realize there's no way that's 90 degrees. So we can't do that. Instead, extend the line and then bring down your perpendicular, and you will have the height, which is known as the altitude, and that is how you do it for a triangle that is obtuse. That is my nudge for when you're doing it on a parallelogram that is long and narrow. So long and narrow parallelogram, something like this. How would you find the altitude to the short side? Okay, there you go. That's the push. I hope that it helps. And again, finding an altitude to a parallelogram is very, very similar to finding an altitude to a triangle. Nudge, nudge, wink, wink. Give that a shot. If you have other questions, please don't hesitate. Reach out. Let me know. I can meet you in Zoom, on campus, in person. I can even make a video just like this for you with whatever question you might have. All right, that's it for now. Off you go.